Okay, hello everyone. So today we're going to introduce you to a set of new shapes. And this set of new shapes is what we call polygons. Alright, so polygons come from the word poly and gon. The naming poly meaning many, okay, and gon being sides. Okay, so we are looking at shapes with many sides. So for polygons, we are going to extend from triangle, great, object with 3 sides. And previously we looked at object with 4 sides, the quadrilateral. And we're going to extend this all the way to more sides, 5 sides, 6 sides, 7 sides, 8, 9 and 10. Alright, and so on and so forth. Now, and when we mention polygon, we specifically want closed shape, meaning like this, right? Is this a triangle? This is not a triangle. It has to be closed. Okay, and the other one, for example, if I want to draw something with 5 sides, it will be 1, 2, 3, 4, 5. It cannot be like this. It has to be something like this. All right, it has to be closed. Okay, 5 sides. Okay. Alright, so the first thing that we need to know is how do we draw these objects, and based on these objects, what name do we give them? So for example, an object with 3 sides is what we call a triangle. An object with 4 sides is what we call a quadrilateral in general. And an object with 5 sides is what we call a pentagon. Now it can be 1, 2, 3, 4, 5, and all the sides are the same. We call this a regular pentagon. Okay, it will look something like this, and it can also look like this: 1, 2, 3, 4, 5, or it can also look like 1, 2, 3, 4, 5, and then these two are 90 degrees. Also can, it like a house, something like shaped like a house. Also can. As long as the thing has 5 sides, we call it a pentagon. However, the difference between these two pentagons is the one on the left, this one over here, right, has all equal sides. Okay, but not necessary lah. Okay, it's just an example. Okay, now for 6, hexagon will be something with 6 sides: 1, 2, 3, 4, 5, 6. Okay, so the one with all even sides would look something like this. Alright, and then you got some wacky ones at 1, 2, 3, 4, 5, 6. Yeah, it's also a hexagon. Okay, alright, so on top of the naming, okay, so how do we pronounce the name? You can realize that for objects with 5, 6, 7 and so on, right, the naming end with a gon. Okay, so you have something gone, something gone. So in simple terms, you're actually looking at 5 gone, 6 gone, 7 gone, 8 gone, 9 gone, 10 gone, and so on and so forth. Okay, however, for numbers less than 10, or actually like in general numbers, we use words to represent the numbers. So something with 5, we call it penta. So the name of the polygon is actually called pentagon. Alright, 6 is hexa. Alright, from the hexadecimal thing. So hexa means 6. So hexagon, 6 sides. 7 would be heptagon. Right, 8 octopus, so octagon. 9 nonagon, and 10 decagon. Deca from the unit, like deci would be 1 over 10, like decimeters and so on. Deca would be 10 times of the thing. Alright, so deca means 10, like decade. Alright, so yeah, so the namings, we need to know the names for at least until 10 sides. Alright, obviously there are shapes with more than 10 sides. Okay, so you can see that there are like even wacky names. For example, things like you can see that 11 is called hendecagon, 12 is called dodecagon, right? 15 is called pentadecagon, 16 interestingly called hexakidecagon. Alright, and so on and so forth. Like, it's going to be confusing to remember so many. For now, we just need to focus all the way to 10. in terms of the naming. Okay, and in this chapter, on top of knowing the shapes, okay, we need to know the shapes and the names. We also need to know the properties, alright, of the interior angles and the exterior angles. Okay, like what we did with triangle and quadrilateral, we look at the amount of angles and so on. Okay, we're going to do the same for polygons. Okay, so before we go on, we need to differentiate what are interior angles and exterior angles. So this is what we see in triangles last time, right? So for a pentagon, right, we have an example pentagon over here, right, for a pentagon. Okay, now the angles inside, right, the angles inside, so like A, B, C, D and E, these 5 angles are your interior angles because they are inside the angles, they're inside the shape. So you have your angle A, right, you have angle A, angle B, angle C, angle D and angle E. They are inside, alright. Whereas for the exterior angles, alright, we have our P, right? So P, so P, Q, R, S and T. These will be your exterior angle because they are outside of the shape. And the thing about exterior angle is it is not just any exterior angle, it's not just this. Okay, before that happens, you have to extend a straight line out from the shape and take the angle adjacent to the interior angle. Alright, so for exterior angles, we have angle P, angle Q, angle R, angle S and angle T. Alright, so the main relationship between your interior and exterior angle would be that particular interior angle, right, plus the particular exterior angle, okay, for the same side, for the same junction, will be always 180 degrees. What is the reason behind this? Because they are adjacent angles along a straight line. Alright, there's no need for us to quote this all the time. Or maybe you may need to quote this sometimes, alright, depending on question, but they are added up to be 180 degrees. So this is one important fact that you need to know first. Okay? Alright, and then you can see that in the next video, we're going to use this to solve other problems, alright? And then in this video, right, we want to look at the interior angles of the different shapes. Okay, so first let us go to page 2 and page 3, and on these 2 pages we are going to explore how to find all the interior angles for these polygons. Okay, so first we are going to follow ancient wisdom on how the civilizations before us determine the angles for all these polygons, and how they do it is actually by chopping the polygons to triangles. For a polygon, because it may be too big, so one way to simplify a big problem is to cut it down to smaller pieces. So for instance, the ancient wisdom is this: we're going to cut the polygon to smaller triangles, and we're going to cut them from the center. So from the center, let's take a look at the first pentagon. From the center, we're going to draw a straight line to this edge. Draw another straight line to, not the edge, but more like the vertex. Okay, we call it the vertex. Okay, same thing, we're going to join straight lines from the center to the vertices. Okay, so now from one pentagon, we're going to have 5 triangles. Alright, we're going to have 5 triangles. And can we find because we're interested in interior angles, can we find the interior angles of all the 5 triangles? We can. So there are actually 1, 2, 3, 4, all these angles. You see all these angles here are the interior angles of the individual triangles. Okay, Now, however, in order to look for the interior angles for the pentagon, we only want this one. What we don't want is the angle at the center. That's what we need to remove. That's what we need to minus off. And you can see that all these extra angles at the center is actually 360 degrees. So what will be the sum of interior angles for our pentagon? It will be 5 triangles, so 5 times 180 degrees, correct? And we need to subtract off 360 degrees over here, because we have to minus the angle from the center. Okay, so we are going to have this 540 degrees. So all the angles in the pentagon, so 1, 2, 3, 4, 5, they're all going to add up to 540 degrees. Okay, now let's move on to the 6 sides, the one with 6 sides, our hexagon. Same thing, we are going to split this into triangles from the center. Okay, so I'm going to have one here. Oh dear, this is so difficult. Okay, 1, 2, 3, 4, 5, 6. So we have 6 triangles there, right? 6 triangles. All right, same thing. We are going to look at the interior angles of all these small triangles, and the interior angles of this triangle actually include the angles at the point at the center. So what we want are those at the side, okay, as you can see at my ugly highlighting, and what we don't want is the one at the center. So we have 6 triangles, right? The angle at the center is 360 degrees still, so we're going to have 6 triangles, so 6 times of 180 degrees minus off our 360. All right, so we are going to get 720 degrees. So all the 6 angles, all the 6 interior angles, all right, all the 6 interior angles add up, you'll get 720 degrees. Okay, so this would be for hexagon. Now for heptagon, let's do one more, and then I think you can find the pattern already. Alright, so for heptagon, okay, we have 1, 2, 3 lines to the vertex, 4, 5, 6, and 7. Right? 7. So we want the angles from, okay, we want all these angles at the corner, right? And we don't want the angle in the middle. Okay, so we have 7 triangles minus off your 360 degrees. So 7 times 180, right, minus 360 degrees. Okay, so it's gonna be 900 degrees. Okay, all right, so I think you can see the difference. Alright, you can see the difference between these two. Alright, so for an n-sided polygon, right, we can form n triangles. Okay, and we have to subtract off the 360 degrees in the center. Okay, so the general formula for us to find the sum of interior angles, all the blue angles in any sided polygon n, we have 5, 6, and 7. I think we can do it now with the pattern. We can do it for any sided polygon, and this n would be a general n, right? So what we can do is we can form up a formula which is n times 180, so 180n minus off your 360 degrees. Okay, to get your to get your sum of interior angles. Okay, so based on this approach, the sum of interior angles of an n-sided polygon would be 180n, okay, degrees minus 360 degrees, or n times 180 minus 360 also can. Okay, this form 180n minus 360 would actually help you in your algebra a little bit. Okay, you can also put n times 180 if you're more comfortable with that, is also fine. Okay, so based on the first approach, the first formula that we have is 180n minus 360 to get all the interior angles. Okay, without further ado, let's push on to the next page. I'm going to introduce you to an alternative formula. Okay, so in page 3, we are going to look at method 2, and based on method 2, we have our second formula for sum of interior angles. Two formulas for the same thing. Okay, so so here now pentagon. Now the previous approach is we chop the big shape up into triangles. Okay, and for this approach, we're going to do the same thing, but how are we going to chop it up will be very different. We are going to cut it such that we're going to take one edge at the center and we're going to cut it up. Okay, join lines to the other two sides. Okay, and we are still forming triangles, but we will form less triangles this round. So how many triangles do we have? We actually have 3 triangles. Alright, so the sum of interior angles is just 3 triangles. So 1, because we have 1 triangle over here, we have our second triangle over there, we have our third triangle over here. For this case, we don't have to concern ourselves with the angle in the middle. Okay, we just want all these 5 angles over here. Just nice. Okay, so the sum of angle of a triangle, sum of interior angles for this pentagon now would be 3 triangles worth of 180 degrees. So you just simply 3 times 180, and you can actually see that it times up to 540 degrees, and it's the same like what we did before. Okay, now similarly for hexagon, okay, I'm just going to do a bit faster. I'm just going to like cut from one side of the hexagon instead from the center. Okay, cut from one side, and you can see now we have 4 triangles. 4 triangles, and because we don't cut at the center, we can just take all the interior angles of this triangle. Okay, so it is just 4 triangles of 180 degrees. So it's just 4 times 180. So we are going to get 720 degrees, which is also the same as our previous findings. And for heptagon, and as you can expect, it's going to be the same. Okay, it's going to be the same here. Okay, so we have 5 triangles. Okay, 1, 2, 3, 4, 5 triangles, and each triangle, the sum of angle is 180. So 5 times 180, we're going to get 900 degrees. Same thing. So all these angles here, right, as you can see, they all add up to 900 degrees. Okay, so for an n-sided polygon, so what would be the pattern like? So for something with 5 sides, we have 3 triangles. For something with 6 sides, we have 4 triangles. For something with 7 sides, we have 5 triangles. And lo and behold, for something with n sides, we're going to have 2 less of triangles. So it's going to be n minus 2 triangles. Alright? And the sum of interior angles would be n minus 2 multiplied by 180 degrees. Okay? So based on this approach, we're going to get n minus 2 times of 180 degrees. Alright? And as you can see, if you expand, you are actually going to get 180n minus 360, which is the same as our first triangle. Okay? So let me conclude. Okay? Let me conclude on this segment over here by going back to the first page. Okay, so let's go back to the first page. Okay, so first, using this approach, we can find out our sum of interior angles. Okay, and we actually have 2 formulas to find out the sum of interior angle. Okay, so we have formula number 1. The first option would be 180 times n minus 360 degrees. The second formula, okay, should be equals to sum of interior angles. Okay, second formula would be just n minus 2 times 180 degrees to give you your other sum of interior angles. Okay, alright, so two formula for the same thing. So actually from here onwards, you just need to focus on one. Just choose one and just remember them. Okay, just choose one of the formula and remember them. Okay, so select which one that makes the most sense to you and memorize it. Okay, commit them to memory, and this will help you to find and solve problems related to these polygons. Okay, so in the next video, we're going to talk about sum of exterior angles and also try to start to solve some of this question. Okay, so stay tuned for part 2.